Hey guys, today we're talking more about solving equations. But first, let's just remember what we did in Investigation 7. We had to make sure that we kept our equations balanced. And so whatever we did on one side of the equation, we had to do on the other too. So we could do things like adding or subtracting or multiplying and dividing both sides of the equation by the same number. And we were doing this with the goal of isolating the variable while keeping our equation true. So we usually did something like divide both sides by this coefficient of x, or if it were a fraction, or even a whole number, another way of thinking about it is multiplying by the reciprocal. So we could either think about dividing both sides by 8, or multiplying both sides by the reciprocal, 1 over 8. When it's a whole number, we usually just think about dividing both sides. So for this one, for example, we might think about dividing both sides of the equation by 8. And then this would give us, these would cancel. We'd have just 1x, or x, equals 4 divided by 8, which is 1/2. What about in this case? In this case, we could divide both sides by 4/5 because that's the coefficient, but it's easier maybe to think about it as, instead of a division problem, multiplying by the reciprocal. We know if we multiply by the reciprocal of this coefficient, this is also going to just cancel out and leave 1x. So this is going to take us to x equals 4 times 5 over 4, which actually just happens to be 5. What about in this case? Here we have 4/5, but it's not positive this time, it's negative. And so if we multiply both sides of the equation by 5/4, which we might try to do, we'd get that these cancel still, and we have x, but it's not a positive x this time. It would actually be a negative x. And so we would have that negative x equals 5, but that's still not what we want. We want this x all by itself, and this negative sign is kind of getting in the way. But what could we multiply a negative by to make it positive? If we have a negative x, what if we multiply that by -1? If we multiply both sides of the equations by -1, then actually we have a negative times a negative, which is a positive. And so that'll give us that positive x by itself, and that is equal to -5. I should be really careful here to make sure that everything is in parentheses. Otherwise, that looked a lot like 5 minus 1, but it's actually 5 times -1. So this is fine. We could do it in 2 steps like this. But the other thing we could have done is straight from the beginning, we could have said, to get rid of this -4/5, I can divide by -4/5, or that would be the same thing as multiplying by -5/4 on both sides. If we had multiplied by -5/4 on both sides, that would have immediately canceled out and become just 1x over here, and then -5 on this side. Well, what about this mixed number? Well, we want to divide by 1 4/5 on both sides, or multiply by the reciprocal, but it's hard to see what the reciprocal is for this, the way it's written right now. Let's change this to be written as an improper fraction instead of a mixed number. So what would that be? 5 times 1 is 5, plus 4, 9/5. So this equation actually says this. Okay, so I haven't actually done anything. This is still exactly the same as this. I've just rewritten it as a mixed number, or sorry, as an improper fraction instead of a mixed number. So now it's a lot easier for me to see what the reciprocal is. Now I know I can multiply both sides by the reciprocal of 9/5, which is 5/9. This is all going to cancel out and leave just 1x. And on here, nothing can cancel, so it's just going to be 29ths, or 2 and 2/9. What about on this side? Well, you might be able to think about it this way. What did we do here? We had to either divide both sides by that negative coefficient, or multiply both sides by the negative of this reciprocal. So we could think about that here too. We could either multiply both sides by negative 1/8, the reciprocal of 8, or we could just divide both sides by negative 8. Maybe in this case, that might be the easier way to think about it, since it is a whole number, or an integer at least. So if I divide both sides by negative 8, then this is all going to cancel. So on this side, I just have x. And on this side, I have 4 divided by negative 8. And if I look at those numbers, I know that's going to reduce to a half. But I have a positive divided by negative. And so because those have opposite signs, we have one positive and one negative, that answer is going to end up being negative. That maybe should make sense, right? That we had this one up here was positive, and here we had one negative sign in there. So our answer is kind of the same, except the negative version of it. What about this one? This kind of looks like what we had up here, kind of in the middle of solving this problem. And so we could just multiply both sides by negative 1. And that'll turn us into a positive x equals negative 1 times 4, which is just negative 4. Okay. Ooh, yikes. Okay, so if you can see it, to take some notes, these are our steps. So we want to change any mixed numbers to improper fractions. We want to multiply both sides by the reciprocal. And we want to remember that a negative times negative 1 becomes positive. So anytime we have a negative coefficient in here, whether that's negative 1, there's kind of a hidden 1 in here, negative 8, negative 4/5, we want to make sure that we are multiplying by negative 1 or dividing by negative 1. Really, it's going to work out the same way. So we first change any mixed numbers to improper fractions. We multiply both sides by the reciprocal of that coefficient, which is the same thing as dividing by that coefficient. And if we have a negative, we need to make sure that we're dividing by that negative sign as well, or multiplying by a negative 1 at the end. Okay, why don't you pause that so that you can write that down? And then when you're ready, let's move on to the next slide. So for these, what I want you to do is I want you to think about first just what would you multiply both sides of the equation by. We'll worry about solving for the variables when we finish thinking about that. But for now, I want you to do kind of the hard work of thinking about what would you actually do to multiply. And then you can multiply or divide later. So what about in this case? This is the case where it's already a fraction, it's not a mixed number. This is kind of like what we've seen before in Investigation 7. And so we'll end up just multiplying by the reciprocal, right? But if we multiply this side by 5/4, we have to multiply this side by 5/4 too. What about this side? We have a mixed number. So our first step is to change that into an improper fraction. So that's going to turn into, let's rewrite it. This is actually 10/3. What would we multiply both sides by? Think about that. Pause it if you need to. We would multiply both sides by 3/10. What about this one? What do we need to do? Again, step 1, we need to change any mixed numbers to improper fractions. It's going to be easiest for us to do that division or that multiplication if we go ahead and change this to an improper fraction too. So I'm going to go ahead and change this into 5 halves times c equals 15 eighths. And then what would I multiply by? Which reciprocal is it? Sometimes people get confused. They want to multiply by, they're not sure if they should multiply by the reciprocal of 5 halves or 15 eighths. But our goal, remember, is to get the c by itself. So we want to multiply both sides by whatever it takes to get that c by itself. In this case, it would be the reciprocal of 5 halves. So it's always multiplying by the reciprocal of c, the variable's coefficient, not what's on this other side. All right, so we know that everything's right if all of these things cancel and we just have one c at the end. How about this? There's no fractions here. We could think about it as multiplying by the reciprocal of -3, or we could just think about dividing by -3, right? Either way you want to think about that is fine. But just keep in mind that this answer is going to be negative, right? What about this one and this one? I want you to think about these two on your own and bring the answers to these two to class tomorrow. So I want you to multiply both sides by something to isolate the variable. And then these two, at least, I want you to solve. You could solve these ones too if you want. All right, I'll see you tomorrow. That's it for today.